Can the universe be endlessly vast, or is there a final frontier where everything stops? It's a question that tickles our curiosity as we delve into the cosmos's secrets. From what we've pieced together, the universe made its grand entrance about 14 billion years ago and has been on a never-ending expansion spree. You'd naturally assume that something that keeps getting bigger must eventually hit a limit. To some extent, that seems logical. However, there's a twist in this cosmic tale. The speed of light puts a cap on what we can see. Because light travels at a finite speed, we're limited to observing only those parts of the universe whose light has managed to reach us in the last 14 billion years. Our window into the universe is essentially a sphere with us at its center, what scientists call the observable universe. But here's where it gets a little more complex. As the universe expands, the most distant objects we've spotted, whose light is just now reaching us, are actually 45 billion light-years away. This means the observable universe extends over a radius of 45 billion light-years, containing an estimated 200 billion galaxies, each home to hundreds of billions of stars. At its core, we face a boundary, not in space, but in time itself, a sort of cosmic deadline after which the universe's past no longer unfolds. This limit is a conceptual one, challenging our traditional notions of boundaries. The reality that lies beyond what we can see is immensely vast, and its true extent remains a mystery. This presents us with two scenarios: the universe is either vast but finite, or it infinitely sprawls into the cosmos. Consider the finite universe concept. It's akin to filling it with a definite amount of ice cream. A ludicrous amount, certainly, but limited all the same. Herein lies an intriguing puzzle. A finite universe suggests the existence of an outer limit, a space where it all ends. And yet, what lies beyond this boundary? The universe, by its very definition, includes everything. So, how could there possibly be something outside of everything? It's a question that bends the mind, but physics offers an ingenious solution: a universe without edges that nonetheless houses a finite quantity of ice cream. Imagine a finite universe as an orange and an ant so small it sees only a part of the orange's surface. This scenario mirrors our own perception of the universe, a mere fragment. However, as the ant travels across the orange, it eventually makes a full loop, ending up where it started. The orange peel, therefore, is finite without having a discernible boundary. Our universe might not exactly be akin to an orange's surface, but it potentially mirrors a more complex shape. Imagine a hypersphere, where the fabric of three-dimensional space folds in on itself. It's a tough idea for our minds to fully grasp. The essence here is that this model lacks any borders or exterior. Our perception of the 3D world is similar to the ant's journey on the orange peel. Travel straight long enough in space, and you'd end up back where you began, right here on Earth. How do we wrap our heads around such concepts? The actual physics involved is intricate, necessitating a bit of simplification and, to be honest, a touch of imagination. Essentially, everything boils down to gravity's role. Mass distorts space-time, generating gravity. This distortion is most intense near large masses but diminishes without ever truly ending, subtly pulling at spacetime's very fabric. Theoretically, this could bend the universe back onto itself, creating the so-called hypersphere. If this concept seems baffling, rest assured, you're in good company. If we're living in a hypersphere universe, figuring out its dimensions poses a unique challenge. On Earth, the way objects vanish over the horizon gives us clues about our planet's roundness. Scientists have looked for a comparable edge in the cosmos to understand our universe's true scope, but without success. This absence of evidence suggests that if our universe takes the shape of a hypersphere, its enormity makes it appear flat from where we stand. For the math to work out, this cosmic hypersphere must be significantly larger than what we can see, no less than 1,000 times the size of the observable universe, and potentially up to 1 trillion times more expansive. Yet, for some researchers, even this concept doesn't fully capture the universe's complexity. They propose an even more unconventional shape. Imagine the universe as the glaze on a donut. Yes, a hyperdonut, equally challenging for our minds to picture. This theory implies that if you traveled straight long enough, you'd loop back to your origin, though the journey would vary depending on the direction taken. This hyperdonut universe would not have a consistent spread of matter throughout. Thus, two spaceships heading off in divergent paths might find vastly different routes back home. This peculiar geometry could also warp the journey of light from far-flung galaxies, casting a kaleidoscope of cosmic reflections and creating a bewildering Hall of Mirrors spectacle. Picture spotting distant celestial bodies in two distinct locations, yet experiencing them at different times due to the varied lengths of time their light takes to reach us. It's as if you're witnessing the birth of a star directly in front of you while simultaneously observing its demise on the opposite side of the cosmos. Considering the unique structure of a hyperdonate universe, it paradoxically represents the concept of the smallest possible universe, potentially only marginally larger than our current observable universe. However, its scale could also stretch to infinity, leaving us with more questions than answers. Now, let's delve into the idea of an infinite universe, a realm without end. What does this entail? Interestingly, the predominant cosmological model adopted by scientists suggests that the universe is indeed infinite. While this model is mainly utilized for understanding phenomena within our observable domain, its implications hint at a universe that extends far beyond any limits. The concept of an infinite universe, stretching out endlessly without borders, challenges our comprehension. Everywhere you look, the universe continues, offering more and more in every direction imaginable. This idea is fascinating and perplexing for several reasons. First, if the universe is truly infinite, does that mean it has always existed and will continue to do so, without a beginning or end? Was there a point when nothingness reigned supreme, only to be replaced by everything that exists now? Although we don't have all the answers, the evidence pointing towards the Big Bang Theory suggests that the universe did, in fact, have an origin. Yet, this leads to an intriguing puzzle. The universe has been expanding since the Big Bang. How does something that is already infinite become even bigger? The expansion of the universe refers to the growing distances between galaxies as time progresses. Indeed, even something infinite can expand, introducing us to the perplexing paradoxes associated with the concept of infinity. The mysteries of infinity grow even more complex when explored further. Imagine embarking on a journey through space, discovering new galaxies, stars, planets, and possibly encountering new forms of life far beyond our wildest imaginations. On this voyage, you might make the most astonishing discovery, encountering an exact replica of yourself, right down to watching this very video. How could this be? At the core of everything, we're made up of a finite assortment of particles, and there's only so many ways these particles can come together. Though the number of possible configurations might appear endless, it's actually finite. Given the infinite expanse of the cosmos, filled in every direction with endless possibilities, it stands to reason that repetition is not just likely, but inevitable over an infinite timeline. Yet, possibility doesn't equal certainty. The infinite universe might endlessly echo the ordinary, leaving the extraordinary, like you, unique in its occurrence. Yet, if the fundamental laws of nature hold uniform across the vastness of space, then somewhere out there, the right combination of gases could form stars and planets. On these planets, the simplest forms of life could emerge from basic chemical reactions, evolving over eons into complex organisms, perhaps even into intelligent beings curious about their universe. Since it has occurred once, the chance of it happening again is not zero. However, the likelihood of encountering an exact replica of yourself, watching this video in this moment, is infinitesimally close to zero. In an infinite cosmos, almost zero might as well be a significant figure. Unfortunately, the chances of meeting your cosmic twin are beyond slim. To find another Earth, identical in every detail, you'd need to journey through space for a distance measured as \10 caret 29 \, or a 1 followed by 100 octillion zeros, times larger than what we can see of the universe. Such a distance renders this other Earth virtually inaccessible, forever beyond our reach. In an endless cosmos, it's conceivable that every arrangement of particles doesn't just happen once but repeats infinitely. This implies there might be limitless versions of you, each existing in their own slice of the universe, all staring into the cosmos, eternally separated by immense distances. Think of the endless variations. In some realities, you might have chosen differently, loved others, or followed unique paths. Maybe in one version, you've decoded the universe's secrets, while in another, you're simply you but with a quirky hat. With an endless array of selves, pondering your true identity becomes a philosophical exercise. Ultimately, it doesn't significantly alter the fact that your existence is as genuine as it could be, whether you're a one-of-a-kind or one among infinite copies. Now, it's time to wrap up our exploration. While these thoughts entertain the possibility, they bridge into the realm of scientific philosophy, beyond current means of verification. The true scope of the universe, whether finite or infinite, eludes our grasp for now. For practical purposes, we live in a universe with a perceivable limit, a frontier not in space but in time. Our world is bound to the observable, likely forever. And yet, this seemingly confined universe is more than vast enough to house the aspirations of countless generations to come. It's a space infinitely ample for the dreams we dare to dream. As we contemplate the universe's mysteries and our place within it, we're reminded of the rich tapestry of knowledge that science, math, and technology continue to unravel, offering concrete answers to our endless questions. What do you think about these deep cosmic questions? Are these theories merely flights of fancy, or do they provide real insights into the universe's mysteries? Share your thoughts and engage in the dialogue about the boundless possibilities waiting just beyond the edge of our known universe.